rational expressions. All right? You probably already all have this down. And I'm going to be looking at my computer only because my notes are at home. Ready to rock and roll at the on my printer. So, all right. So one thing I wanted to talk about really quickly while you guys are finishing writing this, who can tell me? Who can tell me what we would do with this? Just think about it a minute. Does it mean good? So it does not equal this, right? And I'm just going over this because I know that myself and you guys sometimes have an issue with this. So what this really means is x plus 2 times x plus 2, okay? Just a really crucial thing to look at, all right? And this is called, well, if we had a negative here, this would be called the difference of two squares, all right? So let's move on. So we're good with this, right? Yes?
X minus 3. Oh, okay, I'm sorry.
No, you're good. Okay. All right. So the next thing we've got here, I'll let you write this and then we'll go over it. All right, so a rational expression is in its simplest form when the numerator and the denominator are polynomials that have nothing in common or have no common factors, okay? So in simplest terms, sorry, or simplest form, sorry you guys, if there aren't any factors on top, that can cancel out with the factors on the bottom. All right? So that's just kind of a fancy way to put that. I'm going to move this up a little bit. You guys cool to this point right here? Okay, so we look at this. And if we're wanting to cancel out things from the top and bottom or see if there are any of those, what do we need to do first? Yeah, right. So when we do that by what? Factoring. Now, we talked the other day, or at least last time I was in here, we talked about the three ways to factor are, go ahead and call them out, good old plug and go, right? Okay? Graphing or quadratic formula, right? All right, so most of these, all you're going to have to do is just find simple binomials, all right? And what Mr. Mitchell said was look for one of those, either the numerator or the denominator, that looks the simplest to factor. And which one do you guys think looks like it's the easiest to factor?
Numerator.
Okay, let's start with the numerator. Okay. All right. So we're looking for factors of 6 that equal 5. So we've either got 1 and 6 or 2 and 3. Since we've got a positive here and a positive here, we know that our inner terms are both going to be positive, right? And we know that this can only be an x because x times x is the only way to get x squared, correct?
Yes.
Okay. So you guys told me 3 and 2. All right, so kind of a thing to look for, since you guys are practicing how to do this, we're most likely going to have one of these binomials on the bottom too. All right, so when you're factoring, if there's more than one set of factors, like we said, 6 was 1 and 6, or 2 and 3. So you're looking for something that's going to look like this up here, right? And since we have a negative next to our constant term there, what did that mean? And this is negative. What do our signs need to look like? Good. So we know it's going to be something like this, correct? All right. So we're going to want a -1 left over, and so we're going to be using the same two numbers, right? Which one do we want to put next to the negative?
6 is the bigger number.
Mm-hmm. So, like this, whoa. I don't even know what happened there.
I was writing for you.
Rage. Okay. All right. So does that work, you guys? So if we FOIL this out, let's FOIL it out really quick. So we've got x squared, good, and we've got 1x and -6x.
Oh, yeah, see,
All right. I don't know. That one won't work, will it? Okay. Now, what is one thing we should see right away in seeing the 1 and the 6? Does it match anything at the top? Nope. Cool. All right, let's get rid of them. And this. All right, what are we going to put in there, guys? What's going to go next to our negative?
What if we showed them the factors of 6?
I think he just liked to play with it over there, is what I'm
Okay.
thinking. Okay, so those are our factors. And the 3 is negative because? Good, we're left with a -1. All right. Okay, so we've obviously got two things that cancel out, correct? We've got this and this look the same, so we can put our little lines through there. And we come over here. Now, there's one thing we probably should look at before we cancel anything out. All right? We're looking at this, and remember we were talking about asymptotes and wholes, right? What can x not be?
3.
Good. So x cannot equal 3 and -2. A proper form would have been to put the -2 first, but that's not really important. All right. So we come over here and we can rewrite this x plus 3 divided by x minus 3. And our x cannot equal 3 or -2. What about this process doesn't make sense? All right, so I'm going to ask you guys a question. How could I make this more engaging for you other than just sitting there being not interested? How could I make this more appealing? Any thoughts? This is our answer right over there. All right, so let's look at this next one. All right, we know we have to factor it. So we're going to have this on top and this on the bottom. All right. Which one looks like it's a little easier to factor? Yeah, start with the denominator. Because it does not have a coefficient in front of its leading variable, right? So we know that this is going to be x and this is going to be x for sure. Positive, positive, So that makes both of our things positive, right? Okay, so we're looking for factors of 3. Well, 3's prime, right? So the only thing we got going for it is what? 1 and 3. Good. All right, so now we know we're going to be looking for something on top that is going to look like one of our factors on the bottom. All right? So we're going to look at our leading coefficient. We can't break it up. It can only be one way, correct? Hello? If you understand, put a finger up. If you don't, put 2 fingers up.
Let's talk about this number right here. How many different ways can you factor 3?
1, okay. What I was saying was that 3, because sometimes when you have a leading coefficient, if you had a leading coefficient that was 4, then we could either have it as 2x and 2x, or we could have 4x and 1x. So in this case, since 3 is prime, which means it only is times 3 and 1, so only 1 in itself are its factors, we know that we have to have something like this going down, right? And we know that our signs need to be different because we have a negative here and a negative here. So how do you think we might orient that? Minus 2 plus 1. What do you guys think of that? Like this. Minus 2 plus 1. So if we FOILed this out, our O and I, we would have negative 2x and positive 3x. And up here we've got a negative x. So what's that tell us we need to do? Flip? Good, thanks Natalie. All right, so let's do that. Let's go for the eraser.
Oh, we might have an error.
Did I make an error?
No, I don't think you did.
All right.
I think I did have an error. I think I needed this to be a plus.
You guys see why that has to be that way?
Well, in order for you to simplify, which is what the intent here was, I think I had the wrong sign there. We needed this to stay the way you have it. The only factors of 2 are 1 and 2. And 3 then, which is here, is not one of them. So the only way it's going to reduce is if one of the top factors is the same as this one, x plus 1. And the only way to get 2 then is 1 times 2. Okay? But when we look at this, we get negative 2x and positive 3x, which is plus 1x, not minus. So let's change that to a plus so that we can factor it in a useful way. Sorry about that.
No. Well, and the cool thing about that was is we factored the bottom, you guys, so you knew that something on the top had to match up with that. So when it didn't, that'll flag you, oh wait, all right, so something's not right here. There's a sign error, or the teacher wrote it wrong, or anyway, we're all human, right? Okay, all right, so what restrictions do we have on our denominator? Do you guys see why it's negative 1 and negative 3? If you understand why it's negative 1 and negative 3, give me up 1 finger. If you don't, give me 2. Okay. When we're looking at the bottom here, I'm going to do a little side note. We're just going to kind of go up here. All right? And to solve this, this really means x plus 1 equals 0. Okay? So then when you subtract the 1 from both sides, you have x equals negative 1. So that's how we know that we get the -1 there. And then we do that same process for the x plus 3. X plus 3 equals 0. And then when we subtract 3 from both sides, we have x equals -3. And the reason that works is because if we put -1 in here, and we have -1 plus 1, whoa, that makes it 0, okay? And so then that makes the whole bottom 0, because that would make this 0 times, it doesn't even matter what's in there. Or if we put -3 plus 3, then that's 0, and when we multiply it by that, it's all 0. So that's why we do that, all right? So x cannot equal -1 and -3. And again, in proper order, but okay. All right. So now we can clearly see that this goes away, and this goes away. All right. Because they are the same. And you know, we can only cross those out because we're multiplying, all right? If we had a binomial plus a binomial, then we couldn't do that. So it's only that we're multiplying. So then our final answer is over here. We've got 3x minus 2. Thank you. Oh, I wrote the wrong thing, right?
No, you wrote right. I was erasing to make room and you.
Oh, okay. All right. So our final answer is this. And then you have to go all the way over here to find out what the restrictions on your denominator are. Okay? Okay. Now, I just need you guys to write, multiply. A number of these need to be factored before we can do anything, right? Because nothing looks the same at this point that we can get rid of, right? So, which piece would you like to start with first? Okay, well, we'll start with this baby right here. X squared minus 4. X squared minus 4, okay, is something called the difference of two squares. All right? And you probably remember that from Algebra 1. Okay. So we know the x's. Now, in order to not have a middle term, what do we know about the signs? How do we get rid of O and I in our FOIL? They do. Because remember, you guys, yeah. So we have opposite signs, all right? And 4 can be either 1 or 4 or 2 and 2. And it has to be 2 and 2 since it made the things in the center go away, the O and the I. So we're going to do 2s. So we can see if we do our O, which is the outsides, we have -2, right? -2x. And if we do our insides, we have +2x. So they just cancel each other out, right? If you understand, give me a 1, and if you don't, give me a 2. Thanks, you guys. Okay. All right. So I'm just going to erase these really quick because I want the room. All right. Okay. So, all right. So we can come over here. I'm going to put my little multiplication sign. And this one cannot be factored anymore, so we're just going to leave that there. All right? So let's look at this bottom. Okay, we have no inner terms again. What does that mean?
Opposite sign.
Thank you. Very good. All right, and we know that we got the x, and, well, 1 can just be 1 times 1. So there we go. All right. term. Okay, well, you know, it's got some variables, but there's no constant. Can you guys see anything there that we can factor out? Yell it out. What can we factor out of here? Good. So we can factor out an x, because there's an x in both terms, right? So we've got x plus 2. All right. Now, let's look at our bottom, you guys. Before we cancel anything out, we need to make the restrictions on the denominator. And truthfully, something I forgot to do many times in my math career. All right, so what can x not equal? What about this one? X cannot equal, yell it out. -1. Okay, so x cannot equal -1, 1, and -2. Now remember, you guys, we don't have to do anything with this x that we pulled out, because if we came over here, remember the inner terms we set equal to 0, so x plus 2 equals 0, and that's how we got the -2. If we take, you know, x equals 0, well, then that just makes it all 0, right? So that's why we don't have to deal with that. All right, so here we've got our restrictions. Good. All right, so let's cross some things out. All right, we've got one here and one here. We've got one here and one here, correct? You guys see anything else that we can get rid of?
X plus 1.
Got rid of x plus 1. All right, I think we're done. Now, when you go to write your answer, you guys don't forget about this little x hanging out there, because it didn't go away. We just didn't have anything, we didn't need it to make our restriction. So then we've got on the top, or in our numerator, x minus 2, and then on our bottom, we've got this and this, so we could just write it as x times x minus 1. Okay? Yes, ma'am.
So is 0 not one of the restrictions?
Right,
No, it is.
it is.
X can't be a restrict, there can't be 0.
X is 0, will still be dividing the term.
Right.
Oh, yeah, you're right. Okay, so how would we say that then? Would we just put that up in our restriction?
Yeah. There'd be 4 of them.
Okay,
-2, -1, 0, 1.
okay. So we'll just add our 0 here. Glad someone's paying attention. Okay? All right. Cool. All right, on we go. All right, dividing. Woohoo! All right. So we'll write this and then we'll talk. Adding or subtracting. But when you're doing this, all we have to do is reciprocate what comes after the division sign. So we would rewrite this 2/3 times 2/1. Okay? And then we would have 4/3. Okay? So eventually we're going to do that, so I just kind of wanted to remind you guys, all right? Okay, let's look at what we're going to do. We're going to factor this first, okay? Because we need to make restrictions on our denominators, all right? Okay, so let's go here. Which piece would you guys like to start with? The bottom of the first one? All right, let's start with this one. What are we going to do there? Looks vaguely familiar with no center term to one we had in the last problem, right? Okay. How do we think this might be? When there's no center terms, we need to, what comes in the middle of our, what signs do we have? Good. Very nice. Okay. All right. So we know that to get rid of those center terms, we have to have something times something, the same number.
What's
Okay?
that C word that represents those terms?
Conjugates.
There you go.
Very good. Okay. All right. So we've got a +4 and and a negative 4, right? Okay. Let's take the top portion here. Okay. Well, we know that we're going to have an x and an x, all right? We've got negative 15, but we have a positive in the center. So what does that tell us about our signs?
That'll be.
How do we get a negative here? What times what gives us a negative?
Positive times negative.
Good.
So they'll both be.
Okay, let's look at our factors of 15. What are our factors of 15?
3 and 5.
Yeah, right. 1 and 15, that's not going to work. Right. Okay. So how are we going to orient them? Which is going to go next to our negative? What flags us to that?
5.
The sign right here, right? We want a positive 2 left over. So that means that our 5 has to be positive. Okay? That's a 3. I tried to, I tried to correct my, mistake so you guys wouldn't see it. And well, that worked well, didn't it? Okay. All right. Then we're going to come over here and we're going to divide. And we know the top's going to stay just the way it is because we can't factor it. What can we factor out of that 3x minus 12? It's common in both.
3.
3, good. 3 times x minus 4, correct? All right, so in light of this, what can our denominators not be? Negative 4 and positive 4, right?
When you flip, like when you do the chances, does that mean that it is a negative one?
How about we look at that when we get there, because it's a really good question. All right? Okay. Say your question so everybody can hear that, would you?
When you flip it, does that mean that x plus 1, x can equal negative 1?
Okay. Well, we'll find out. But let's put up here, so with our original factoring, x cannot equal negative 4 and 4, right? Okay. You guys are doing good. Let's rewrite this with flipping our second term over. All right, so we've got x plus 5, x minus 3, x plus 4, x minus 4. Okay, and we're going to multiply, and we're going to flip it. So we've got 3 times x minus 4 and x plus 1. Okay, so we took this term and we flipped it. We reciprocated it, okay? We switched places with the numerator and the denominator. All right, so with our new expression here, x cannot equal okay. Thank you. Now, is there anything we can get rid of right now? Okay. So these go away, right? That looks like it's it. I'm sorry, yep, the 3's still there. Yep. All right, so Mr. Mitchell, will you talk about and address her question, please? Because I'm not sure I know how to answer that.
Oh, well, she was just saying what you wrote here. That once I flip this over, does this 0 have to be represented in our restrictions? And the answer is yes. That's what you're asking, right? And so, absolutely. So you can't forget about this 0, which wouldn't have mattered in this case because we had the same one over here. But you also have to realize that before you get started, anything that was in the bottom, that's all of these, can create zeros that create undefined terms, so we can't ignore them. And then after we flip it over, we have a new one here that can't be ignored. So you have to add that to your list.
Cool. Thank you. All right, so let's put our final product here. 3 times x plus 5 times x minus 3 over x plus 1.
And x plus 1.
Yeah. Can you multiply that?
Oh, yeah, sorry. See how easy it is to forget that, and I'm up here doing it? So just be really cognizant
Rebecca Cutler, please report to the office.
aware of that.
Rebecca Cutler, please
Okay.
report to the office.
All right,
And that's the answer.
yeah, so now what questions do you guys have?
Bring this. Number 1 in our activity says x plus 3, x plus 4 over x plus 1 and x plus 3 times x plus 3, x plus 1, x plus 4. Now, when our x plus 4 is not in parentheses like that, don't be afraid to put it in parentheses. Might help you understand what's got to cancel. Okay? And we're multiplying. So that's number 1. The numbered problems are problems. The letters are solutions. Okay? So we're going to first state all our restrictions. X cannot equal what?
-1, -3,
Negative 1, because negative 1 plus 1 is 0. X cannot equal negative 3, because negative 3 plus 3 is 0. And x cannot equal negative 4. So there's our restrictions. So the answer to number 1 should have those restrictions, and Liz says she's found them already. We'll all search for them in a second. Let's finish the problem. What cancels in this problem? X plus 4 cancels?
X plus 3.
Yeah. I could go x plus 3 in this one or x plus 3 in this one. It doesn't matter.
And x plus
So if you want, we'll go over there. And x plus 1. Leaving us with
x plus 3.
over
X.
1, which is just x plus 3. So we're looking now for the other card. It's L. Oh, it's right there. And so 1 and L need to go together. And you can't see it at home, even though we're recording. But we put them right next to each other, one upside down, the other one
Tape 'em?
together. And yeah, you can tape them together.
Do we have to show the work on this paper?
Yeah.
What's that? You do not have, well, you should have a piece of paper where you're doing your work, and you might as well number it when you do. Now, some of it you may not need to show as much as some of the others, and that's okay. You just show what you need to show
We need the
and
paper.
number it.
So we have our homework. So it's like homework.
Well, no,